So welcome back to another video. And in this video, we are going to see the importance of using the process control such as wait fork inside the program block of SystemVerilog. So let's begin. So we are going to start with the same setup of our threads, and we will have two threads, thread A and thread B, and the thread A will finish before thread B. And unlike the last time, in this time, we will use the fork join none inside a program block. And there we will observe an interesting behavior. So let's go ahead and write a program block. And let's call it fork test. So inside this, first we will write an initial block, and we will write couple of display statements inside two of the threads. So let's write a display statement here also, which will just say the main thread starts. And right after that, we will use a fork join none. So as I have mentioned earlier, inside a fork join none, uh, the process will not, the program flow will not wait for any of the thread to complete, and it will move towards the statement, whatever statement which is written after the fork block. So here we will write two threads. Inside the first thread, we will give it a delay of uh, 10 minutes, and then we will write our display system task. And we will do the same thing with the other thread. We will give it a delay of 20 time units, and then we will write our display system task. So we have our two threads. The thread A has a delay of 10 time units, and the thread B has a delay of 20 time units. So right after that, uh, we will just you write another $display system task, in which we will just write the main thread finishes here, or the main thread finishes. Okay, we are done with our program block. Now we will write a test module, and we will write the instance of that program block inside the test module. And let's call the instance as F1. Okay, let's compile the code and check whether we have any compilation errors. Okay, we do have a couple of errors at line number 23. Okay, it should be end module. Okay, now it's fine. It was just a typo. So we will go ahead and start the simulation. So here you will observe the difference between using fork join or the initial block inside a program block versus inside a module. So what will happen if you have used the same setup inside a regular module? So since we are using fork join none, the when we will start with initial begin, this particular display system task will print its message. And after that, since both the threads have a delay of 10 time units and then the other one has a delay of 20 time units, this particular $display system task will print its message. Then the simulation will wait for the other threads to complete. But since we are using fork join none, it will not wait for any of the threads to finish and it will right away execute this particular statement. So then after 10 time units, this $display system task will execute. And after 20 time units, this particular $display system task will execute. And here, okay, it does not matter, but I should have written it like this. But since we are using a uh, program block has a functionality that it exits simulation once it reaches the end of any initial block. So here we have one initial block, and since we are using fork join none, which is non-blocking in nature, it will not wait in for any of the thread to complete, and then it will proceed to this $display system task, and right after that, uh, in the same time slot, it will reach the end, and when it reaches the end, it will not wait for the other threads to complete. It will instead just exit the simulation. So that's how a program block function. So let's go ahead and run the simulation. First, I will compile the code. Let's start the simulation. And let's run the simulation. So as you can see it right here that we are seeing all of the threads to finish. So the wait fork right here is just holding the execution flow of all the threads. It blocks the code flow till all the threads complete, and right after that the $display system task executes, and right after that we encountered the end of the initial begin block. So this is how you could use the process control inside a program block to control the execution of threads. So I hope you find this video useful and stay tuned for more. Thank you so much.